Hello everyone, my name is Nguyen, and today I will solve the real-world case master about the AI integrated logistics 5.0 for model to business reality. Here is my executive summary. The first I will introduce the logistics company. Is a growing logistics provider operating across transportation and warehousing in Vietnam, and the industry become more complex. The company is facing increasing pressure to deliver faster, more efficient, and more sustainable service. However, through our analysis, we identify three critical challenges that are limiting their performance. First, there is the lack of AI and automation in daily operations, leading to manual decision-making and efficiencies. Second, the company lack of real-time visibility as data is fragmented across the multiple systems. And the third one, increasing sustainability pressure is exposing the risk of relying heavily on fuel-based transportation. To solve that problem, we use the digital twins intelligent platform that can reduce 30% of total supply chain costs, 30% reduce the fuel consumption, and saving 30% CO2 reduction. So next, to be better understand the challenges, we analyze both external market trends and weak logistic internal operations. First, from the market perspective, the logistics industry is undergoing rapid transformation. 63% warehouse industry leader globally plan to deploy AI technologies within the next 5 years. Moreover, the global smart logistics market is expected to develop to 22.8% from 2024 to 2034. Besides, Vietnam aims to reduce 12 to 15% logistics cost, saving $45 billion. This creates significant opportunities for those who act and adapt proactively. From the internal perspective, Viet Logistics still face several operational problems. First, operations rely heavily on manual processes and lack of AI integration remains limited, cause the frequent stock out and the delays. Second, data is fragmented across different systems, making it difficult to achieve real-time visibility and coordination. Third, the company still depends largely on fuel-based transportation, which increase both operational costs and environmental impact. These internal gaps combined with external market pressure create a significant pressure. So therefore, Viet Logistics must reposition into intelligent, sustainable, and maintain stronger competitive in the Vietnam and global logistics market. So I decided to suggest digital twin intelligent platform. And so why is the digital twin intelligent platform? Because this platform goes beyond monitoring. It acts as an intelligent layer, enabling the organization to shift from the reactive decision-making toward predictive and optimized decision-making. Ultimately, it also serves as a control mechanism, where insights are not only observed but directly translated to operation actions. The first is the physical access integration layer. At this stage, we integrate IoT sensor data with WMS and TMS into a single unified platform. The second is intelligent digital twin layer. This is the core intelligence engines where AI models are embedded into systems to analyze real-time operational patterns. The final layer is operational execution layer. The key difference here is that we move beyond the dashboard only. Instead of insights are directly translated into actions such as through optimization adjustment, predictive maintenance alert, and improvement in energy and fleet efficiency. And this can help reduce 30% total supply chain costs and 15% reduction in total distribution center. To achieve this goal, at the first stage, I am going to build strong digital foundation warehouse operation. First, I use ceiling-mounted cameras to capture a top-down view of the warehouse. With computer vision, the system can identify and classify goods, people, and the movement. Next, I integrate LiDAR on AMRs, enabling robots to self-locate accurate the detect obstacle during navigation. At the same time, the dimension, weight, scan system records size, weight, and the label at the inbound stage, ensuring accurate data from the beginning. Once the physical layer is digital, I move on to the digital twin and AI layer. The digital twin creates a real-time virtual replica of the warehouse operations, continuously monitoring on activities. The AI system will build a centralized activity map for traffic and movement checking of the warehouse. They can perform ABC inventory analysis to optimize product placement. And finally, optimize space utilization and load capacity. Next, I am going to expand the system to capture deeper operational data from equipment and fleet activities. I deployed the thermal sensors to monitor the equipment temperature and detect abnormal hotspots, helping prevent the fire risk and failures. The vibration sensors is to detect early signs of mechanical issues in conveyors and motors. GPS tracking to monitor real-time location and speed of the fleet. And the last one is onboard diagnostic device to collect engine data such as fuel consumption, engine health, and the driving behavior. By interpreting this data source, the AI evolves from visibility to real operational intelligence. First, predictive maintenance allows the system to detect the potential failure before they happen, reducing the downtime significantly. Second, dynamic fleet management enables real-time risk adjustment in case of disruption. Third, an eco-driving dashboard analyzes driving behavior to reduce the fuel consumption and emissions. Finally, the system can detect incomplete combustion, helping prevent fuel waste and engine damage. At this stage, I am enabling the system to understand, predict, and proactively optimize operations. Next, once data and intelligence are in place, the final step is to convert insight into real operational action. When the inventory level gets low, an automation replenishment trigger will alert before stockout occurs. When the system detects abnormal patterns, it automatically reschedules maintenance before any breakdown occurs, helping prevent downtime and reduce repair costs. Next, another major challenge is limited real-time visibility and fragmented data across the operation. Real-time congestion is detected through the camera analytics. When crowded zones are identified, the system immediately reroutes tasks and redistribute workload to avoid the bottlenecks. Shipment tracking is fully real-time, where delays and deviations are detected early and corrective actions are executed immediately. Beyond the operation efficiency, the system also tackles sustainability challenge in the logistic operation. Energy consumption is often inefficient due to the static lighting and HVAC system. To solve this, the system introduced the smart energy, where the lighting is activated only when the activity is detected. HVAC adjusts dynamically based on the occupancy and the workload. Besides, Vietnam relies heavily on the 70% import of crude oil, and fuel prices are highly increased due to the current war. So with the EV deployment, we can achieve around 30% CO2 reduction in the inner city delivery, efficient operation with 40 package carrying capacity, and fast changing with high operational readiness for the SM vans. So next, to protect the project, I have identified some main risks. We prioritize addressing the cybersecurity and data integrity risks using the end-to-end encryption in AI noise filtering algorithm. So this is the end of my presentation about the case study 2. So thank you for your listening.